So now we learn hurricane. Yeah, hurricane. Exciting. Here since yesterday, so there is another hurricane in the Central American is forming. It's very strong. So we before that Elta. So there is another strong hurricane happened. Eta. Yeah. So why hurricane is so become so intense, so stronger, and and this is because global warming. Yeah, global warming. Hot air can hold more water molecules. Water molecules condense into liquid water, release this latent heat, they produce strong uh, wind. Yeah. So do you remember there is a Hurricane Sandy? Yeah. In later October 12, 2012. Yeah. So then visit our New York. Yeah. From here you can see the hurricane from this is Sandy. This is October 26th. Then come arrives to New York on October 30, about the 4 days. Yeah, from two category two become a category one, then it arrived us. Yeah, 2011 also there is one Hurricane Erin. Yeah, came to New York. This started at August 20, then moved to New York on August 28th. You see, totally 8 days. Hurricane is different from tornadoes. Yeah, tornadoes is also very damaged. Uh, Phenomenon, however, is very narrow. Yeah, and a very short time period. Yeah, 20 minutes. Yeah, half hour. This hurricane came moving. Yeah, you can see big size and about a week or 10 days. So there's a very famous hurricane, the Katrina. Yeah. So from here, you can see the unique characteristics of the hurricane. It has an eye in the center. Yeah, that's low pressure. Yeah, hurricanes are strong or not strong depends on the pressure in the center. This center is so important. The center is a clear sky, no wind, sunshine. Yeah, so and this center is warm. Yeah, all these characteristics are very, very important for you to understand. Yeah, this hurricane self-organization, self-moving. Yeah, and also there are a lot of multiple choice in your final related to this center. Yeah, hurricane is strong rotating column of the air, right? Rotating, yeah. Hurricane, the rotating. So this, wow, these two hurricane, the direction of the rotating is opposite, yeah. So one is clockwise, another is counterclockwise. Why? Why? Yeah. So Yeah, because this hurricane occurred in different hemisphere. In the north hemisphere, hurricane they rotate counterclockwise. In the south hemisphere, in a counter in a clockwise. Yeah. So because there is a corrosive force. Yeah. Uh, we learn what is the corrosive force. Here is one multiple choice in your final. Yeah. So that's the rotating direction in the north hemisphere and different from in the southern hemisphere. Corrosive force. What is a corrosive force? Corrosive force is an important force for the hurricane, for the tornadoes. So from here, you can see the non-rotating platform. Yeah. So there's a Peter threw a ball to the Derek. Yeah, to the Derek. So then Derek can catch up. So this is for non-rotating platform. Yeah. However, if this platform is rotating, yeah, in counterclockwise, so this Peter threw the ball to the Derek. So then Derek missed, cannot catch up. So then you see, oh, the path of the ball looks like deflection to the right. Yeah, deflection to the right. So then this this means some kind of force. Then let this ball deflection to the right. This force is called corrosive force. Yeah, corrosive force. So for our Earth is rotating, right? Yeah, we have morning, noon, afternoon. Yeah, so it's rotating 24 hours, 360 degree, right? It's rotating. Yeah. So let's. So this is for airplane from Beijing to the New York. Yeah, you see that from Beijing to the New York. This in the north hemisphere, due to corrosive force, this airplane will deflect it to the right. Yeah, so the pilot must be make adjustment for the direction. Yeah, otherwise we'll go to Florida. Okay, there's a corrosive force. Yeah, corrosive force is a force. Force has two properties. Yeah, one is direction. The force must be there in the direction, and another is magnitude. How strong of these forces? So two properties. One is direction. Second is magnitude. So corrosive force, what is the direction? Yeah, the direction in the north hemisphere, deflection to the right. Yeah, in the south hemisphere, deflection to the left. Yeah, so you see red arrow. That is pressure difference. We call the pressure gradient force. Yeah, or PGF, pressure P, gradient G, F, the force PGF. The red arrow indicates PGF direction, pressure difference direction. Yeah. So actually wind should be from high pressure to low pressure. However, in the north hemisphere, deflection to the right. Yeah. Deflection to the right. Deflection to the right. Yeah. In the equator, no deflection, no cross force, no hurricane. That's important for you for one multiple choice. On the equator, there is no hurricane. Yeah, there's no hurricane because there's no corrosive force. Yeah. In the southern hemisphere, so that's the deflection to the left. Yeah. Then use your eye to see the red arrow. That is the PGF direction. That's the pressure direction. Yeah. Deflection to the left. Yeah. So deflection to the left, deflection to the left. Yeah. Okay. That is the direction. And there's the magnitude. Yeah. Cross force, there's the magnitude. CF is the cross force. Is equal to, yeah, omega. Omega is the rate of Earth's rotation. You can make a calculation. Yeah. Rotation, you see, uh, one day how many degree for the Earth is rotating? 360 degree. Divided by the time, that's rate. One day how many hours? 24 hours. 1 hour, how many minutes? 60 minutes. 1 minute, how many seconds? 60 seconds. Yeah. So 24 times 60 minutes times 60 seconds. That's the total seconds for a day. So then you can make a calculation. However, this omega is constant. Yeah, every day the same. Yeah, yeah, every day the same. So that's constant. Another is V. V is wind speed. Yeah, airplane speed. There's a speed. Yeah, so there's a speed. The partial speed. If this speed is faster, yeah, wind speed is faster, Coriolis force is stronger, deflection more. Yeah. If no wind speed, so no Coriolis force. Yeah. Small wind speed, the small Coriolis force. Yeah. So 2 omega V. And another is the phi. Phi is the latitude. Yeah. I think you know is the same phi. Equator. Equator is 0. Latitude is 0. Sine 0 equal. Yeah. So sine 0 is equal 0. So Coriolis force is 0 on equator because this depends on latitude. Yeah. So that's why there's no Coriolis force on the equator. There's no hurricane. Yeah. Yeah. So, and what is 30 latitude in the Earth? Yeah, that is 0.5. Yeah. So, how about the 60 degree in the Earth? The 0.87. Yeah. So that means when this Coriolis force is increasing with latitude increasing. Yeah. So at the North Pole, this Coriolis force is maximum. Yeah. So this is the North Hemisphere. In the Southern Hemisphere, for example, here is negative 30 degree. Saying negative 30 degrees is equal negative 0.5. Yeah. So that's diffraction to the left. Yeah. So this magnitude of Coriolis force. Yeah. Coriolis force is perpendicular to the wind direction. So Coriolis force only can change the partial direction. It cannot affect the wind speed. Cannot speed up. Cannot slow down. Yeah, for the wind. Only change wind direction. In the north hemisphere, diffraction to the right. In the south hemisphere, diffraction to the left. You see the hurricane? Yeah, there's a hurricane. There's equator. Equator, no hurricane is generated, right? Yeah. In the north hemisphere, it's a diffraction to the left. Yeah. In the south hemisphere, diffraction to the left.